Long before there are cemeteries, carved stones, names written in clay, or monuments visible above the earth, there is only a body and a landscape. A person dies beside a river, beneath a rock shelter, on an open plain, or deep inside a cave. The living must do something, even if that something leaves almost no trace. They may move the body, they may cover it, they may return later, or they may simply leave, and the world begins its patient work. Soil shifts, water carries sediment, carnivores disturb bones, roots push through old layers, caves collapse, floods rearrange what once seemed fixed. Tens of thousands of years later, an archaeologist kneels over a fragment of bone and asks a deceptively simple question: was this person placed here on purpose? That question lies at the beginning of the archaeological study of death, and it is far harder to answer than it sounds. A skeleton in the ground is not automatically a grave. A body can enter sediment through accident, erosion, collapse, animal activity, flooding, or the gradual filling of a cave. Bones can move after death. A complete skeleton can sometimes survive without deliberate burial, while a carefully buried individual can later be scattered almost beyond recognition. The oldest possible graves therefore sit behind a wall of uncertainty. Archaeologists are not simply looking for dead people, they are looking for evidence of intention. Before we go deeper, take a moment to like the video and subscribe, if this is the kind of history and mystery you enjoy. The distinction matters because intentional burial is an action performed by the living. It requires decisions. If a pit is dug, labor is involved. If the body is positioned, that position has been chosen. If objects, pigment, stones, or animal remains are added, archaeologists must decide whether they were truly placed there or merely happened to be nearby. None of these steps automatically proves religion, grief, belief in an afterlife, or ritual in the modern sense. But together they can reveal something more cautious: the dead were being treated according to a pattern. The oldest periods make this especially difficult because almost everything that could explain the act has disappeared. No spoken words survive, no wooden markers remain, no woven coverings are likely to endure. Flowers vanish quickly, and even pollen can arrive through insects, wind, or later disturbance. Soft tissues are gone. A gesture that may once have been obvious can be reduced, after 100,000 years, to a slight hollow in sediment and the angle of a rib. This is why serious claims about early burial depend on context rather than drama. The strongest cases are built from many small observations that point in the same direction. Archaeologists examine whether the bones remain articulated, meaning that parts of the skeleton still lie in anatomical relationship. They look at whether the body appears to have rested in a depression or pit that cuts through older layers. They study the sediment filling that feature and compare it with surrounding deposits. Micromorphology can reveal tiny differences in soil structure invisible in the field. Geochemistry may show whether the fill came from disturbed local sediment. Taphonomy, the study of what happens to organisms after death, helps distinguish deliberate placement from scavenging, trampling, decay, water movement, and other natural processes. Even the orientation of the body matters, but only when it forms part of a larger pattern. One bent knee proves very little. A repeated arrangement of bodies in clearly dug features begins to say much more. Caves add another layer of difficulty. They preserve human remains exceptionally well, which is one reason so many famous early burial claims come from caves and rock shelters. Yet caves are also geological traps. Bodies, stones, sediments, and animal remains can accumulate through complicated processes. Narrow passages can channel material into particular chambers. Roof falls can seal deposits. Water can move smaller bones without shifting larger ones. Carnivores may carry body parts inward. Later visitors can disturb older surfaces. A deep cave filled with human remains can therefore look like a cemetery, even when the route by which the bones arrived remains uncertain. Scholars still debate some extraordinary examples for precisely this reason. Open-air sites present the opposite problem. There, erosion, weather, later occupation, agriculture, and changing river courses often destroy the evidence needed to recognize a grave. The apparent absence of burials in some regions or periods may therefore reflect preservation rather than behavior. This is one of the most important cautions in the story. Archaeology records survival unevenly. A society that carefully treated its dead could leave almost nothing behind, while a single fortunate burial in stable sediment might dominate our picture of an entire population. For much of the 20th century, researchers were tempted to turn early graves into milestones on a ladder toward modern humanity. Burial was sometimes treated as proof that a population had crossed a cognitive threshold, suddenly gaining symbolism, spirituality, or fully modern thought. That framework is increasingly difficult to defend. Mortuary behavior does not appear as one neat package, nor does it belong comfortably to a single species. Different forms of body treatment emerge in different regions, under different conditions, among different human populations. The evidence suggests mosaics of behavior rather than one sudden revolution. That makes the first graves more interesting, not less. Instead of asking when humans became mentally modern, a question loaded with assumptions, archaeologists can ask something more precise. When did communities begin altering the landscape because someone had died? When did bodies become the focus of repeated structured actions? When did the dead begin to remain socially present through places, objects, pigments, or return visits? They begin with what survives. And what survives is often modest, a shallow cut in old sediment, a skeleton still curled on its side, a patch of earth with a slightly different texture, a concentration of red mineral pigment, a stone resting where chance seems unlikely to have placed it. None of these is spectacular by itself, yet together, under careful analysis, they can expose one of the deepest changes preserved in the human record, the moment when death stops being only a biological event and begins to leave a deliberate mark in space. That mark is the doorway into everything that follows. The first graves are not simply holes in the ground. They are problems of evidence, intention, memory, and time. To recognize one, archaeology must reconstruct an act from its residue and resist the temptation to fill every silence with meaning. Here, caution is not weakness, it is the method. The evidence remains incomplete. But where multiple lines converge, the earth can still preserve the faint outline of a decision made by people who lived before history had words for what they were doing. The first difficulty, once intention becomes the question, is that the archaeological record does not offer a single grave that everyone agrees stands at the beginning. Instead, the story opens with a borderland of possibilities. Some very ancient human remains lie in circumstances that may reflect deliberate placement, yet the surrounding sediments have been disturbed. The excavation records are incomplete, or natural processes can explain part of what archaeologists see. Other cases are much stronger. Their bodies remain articulated, their positions appear constrained, and the surrounding deposits preserve signs of excavation and refilling. The deeper into the Pleistocene researchers go, however, the more often certainty gives way to probability. That uncertainty has shaped arguments for more than a century. Early excavators sometimes recognized burials by intuition. A nearly complete skeleton in a cave looked deliberate because it seemed too orderly to be accidental. Modern archaeology demands more. It asks whether a pit can actually be demonstrated, whether the edges of that pit cut older sediment, whether the fill differs from the layer around it, whether bones were protected from scavengers soon after death, and whether the body decayed where it was found. A skeleton may look carefully arranged because soft tissues held the limbs together during burial by natural sediment. Conversely, a genuine grave can look chaotic after thousands of years of pressure, water movement, animal disturbance, or later human activity. Some of the earliest proposed burials therefore remain disputed not because the finds are unimportant, but because excavation happened before today's methods existed. Once a site has been dug away, the original sedimentary relationships cannot be recreated. Field notes, photographs, drawings, and museum collections may preserve enough information for reassessment, but not always enough to settle the argument. Archaeology has an uncomfortable rule: a spectacular discovery excavated poorly can become less informative than a modest discovery recorded with extraordinary care. This is why the shape of the grave matters so much. A true burial pit is not simply empty space around bones. It is a feature cut into an existing surface. Its margins may interrupt natural layering. Sediment thrown back into it can have a mixed texture unlike undisturbed deposits nearby. Small fragments from different layers may become combined in the fill. Under a microscope, researchers can sometimes see broken aggregates, disturbed grains, or minute traces of sediment movement consistent with digging. None of these clues alone proves that mourners stood there with tools in hand, but together they can make natural deposition increasingly difficult to defend. The body itself becomes another kind of evidence. If joints remain connected in anatomical order, the corpse probably decomposed largely in place. Hands, feet, ribs, and vertebrae are especially informative because small bones are easily scattered. A tightly flexed position can suggest that the body occupied a limited space, although flexion by itself is not proof of binding or wrapping. The orientation of the head or limbs may matter when similar placements recur at one site. Researchers also examine whether bones show carnivore damage, weathering, trampling, or transport by water. The absence of such traces can support rapid covering, but even that must be interpreted cautiously, because protected natural settings can produce similar preservation. Then there is time. A body can be deliberately placed into a natural hollow without anyone digging a formal pit. It can be covered with sediment, stones, vegetation, or organic material that later disappears. Such an act may have been meaningful to the people involved, yet archaeologically it can be nearly invisible. The category burial is therefore partly shaped by what survives well enough to recognize. What survives in the record suggests that deliberate treatment of the dead may be older than the earliest graves archaeologists can prove. That distinction also protects the story from another mistake, treating the oldest securely demonstrated grave as the first grave ever made. Archaeology can establish only the earliest example currently preserved and recognized with sufficient confidence. Earlier practices may have vanished completely. Populations may have used trees, platforms, caves, water, exposure, or other treatments that left no identifiable archaeological signature. The record begins where preservation and detection happen to meet human action. The Levant becomes especially important because its caves preserve a long and unusually rich record of human occupation. During the Middle Paleolithic, different Homo populations moved through this ecological corridor between Africa and Eurasia. At sites such as Skhul and Qafzeh, human skeletons were found in contexts long interpreted as intentional burials, some associated with ochre or animal remains. Their ages reach back roughly toward the range of 100,000 years and beyond, although individual dates and interpretations differ by site. These discoveries once seemed to fit a simple narrative in which early Homo sapiens displayed burial behavior before Neanderthals. The accumulating evidence has made that sequence far less tidy. More recent work at Tinshemet Cave in Israel has sharpened the problem. Excavations there have revealed articulated human remains in burial contexts dating broadly to about 100,000 years ago. Alongside abundant ochre and stone artifacts, the site is significant not because one object proves ritual, but because the human remains, their placement, the sedimentary context, and associated materials can be compared with nearby Middle Paleolithic sites. Researchers have argued that similarities among Tinshemet, Qafzeh, and Skhul may reflect a broader pattern of mortuary behavior in the Levant, rather than an isolated invention at a single cave. Even here, language matters. Intentional burial is safer than funeral when the evidence cannot reconstruct the ceremony. Grave inclusion is safer than offering when an object's meaning is unknown. Ochre near a body may have been deliberately used, but the symbolic significance of red pigment cannot simply be assumed. An animal part placed beside a corpse may carry meaning, yet archaeology rarely tells us exactly what that meaning was. The temptation to translate material patterns directly into beliefs is powerful because modern observers already know what graves mean in their own societies. Prehistoric evidence does not grant that luxury. The earliest graves therefore emerge not as a single dramatic invention, but as a series of increasingly persuasive cases. Some stand on uncertain foundations, others survive with enough anatomical, sedimentological, and contextual detail to show that a body was intentionally placed and protected. Together they reveal a change that may have happened more than once, among populations that were not all the same kind of human. And that realization leads directly toward one of the oldest assumptions in human prehistory. If deliberate burial appears among early Homo sapiens, what happens when the same standards are applied to Neanderthals for decades? That question has produced some of archaeology's most persistent disputes, because in caves from France to Iraq, bodies attributed to Neanderthals also appear to have been placed in the earth with a degree of care that is increasingly difficult to dismiss. For much of the 20th century, Neanderthal graves sat at the center of a larger argument about what kind of humans Neanderthals had been. If they buried their dead intentionally, then the old image of a brutish population reacting only to immediate survival became harder to sustain. Yet that very implication made burial evidence unusually vulnerable to overstatement. A skeleton found in a depression could be interpreted as ritual by one generation, then dismissed as natural accumulation by another. The strongest approach is neither to romanticize nor to deny, but to ask what each site actually preserves. La Chapelle-aux-Saints in southwestern France became one of the classic cases. Excavated in 1908, the site produced a relatively complete Neanderthal skeleton in a shallow depression. Early descriptions supported deliberate burial, but later critics argued that natural processes might explain the body's position and preservation. More recent reassessment returned to the sediments, skeletal articulation, and excavation records and concluded that intentional burial remained the most plausible explanation. The important lesson is not that one old interpretation won. It is that a century-old find could still be tested against modern taphonomic and geoarchaeological expectations. La Ferracie, also in France, presents a different but related puzzle. The rock shelter contains several Neanderthal individuals recovered from deposits excavated over many decades. Some were found in positions that have long been described as burials, including bodies placed within apparent pits. Because early excavation techniques were not always adequate by modern standards, every claim must be treated carefully. Yet repeated deposition of articulated individuals in the same locality strengthens the possibility that the shelter had become a place where the dead were treated in patterned ways. Scholars still debate the exact number of intentional burials at La Ferracie, but the site is difficult to reduce to a single accidental event. Farther east, Kebara Cave in Israel contributes another important case. A Neanderthal skeleton discovered there preserved much of the torso, pelvis, arms, and famous hyoid bone, while the skull was absent. The body's anatomical coherence and context have been widely taken as strong evidence of intentional burial. The missing skull once encouraged dramatic speculation about ritual removal, but post-depositional disturbance offers less theatrical possibilities, and the evidence does not require a ceremonial explanation. Kebara is useful precisely because it demonstrates how burial and ritual must be separated. A body can be intentionally interred even when the beliefs surrounding that act remain inaccessible. The same caution applies at Shanidar Cave in Iraqi Kurdistan, where multiple Neanderthal individuals were found during 20th century excavations. Some remains clearly accumulated under complicated circumstances, including rockfall, while others became candidates for deliberate burial. Shanidar is especially valuable because it preserves not one simple event, but a palimpsest of occupation, death, disturbance, and later excavation. Its fame has sometimes encouraged the cave to carry more symbolic weight than the evidence can safely support. Yet newer fieldwork has shown that the mortuary question there cannot simply be dismissed as an artifact of outdated excavation. What links these sites is not a single burial custom. Body position varies. Grave architecture is inconsistent. Associations with artifacts or pigments are uneven. There is no secure Neanderthal equivalent of a standardized cemetery extending across Europe and Western Asia. Instead, the pattern is patchy, which is exactly what might be expected from mobile populations living across enormous distances and long spans of time. A behavior does not need to be universal to be real. Comparison with early Homo sapiens in the Levant has made the picture even more complicated. At roughly overlapping times, Neanderthals and early Homo sapiens occupied parts of Western Asia and appear, in some cases, to have treated bodies in ways that are not sharply separated by species. Recent comparative work emphasizes both similarities and differences in burial contexts, rather than a clean cultural boundary. That matters because older models often assumed that mortuary behavior belonged naturally to Homo sapiens and had to be explained away when it appeared among Neanderthals. The archaeological record increasingly resists that asymmetry. There is also a geographic dimension. Caves and rock shelters were repeatedly revisited places. They offered protection, predictable spatial structure, and durable landmarks in landscapes otherwise transformed by seasons and climate. If a body was deliberately placed within such a location, the act may have connected death to a place already meaningful to the group. Some researchers have suggested that burial could contribute to group identity, territorial attachment, or social memory. Those interpretations are plausible. especially where locations were repeatedly used, but they remain inferences rather than direct observations. No grave announces whether the living returned because of grief, custom, ancestry, practical convenience, or several reasons at once. The Neanderthal debate has therefore changed character. The old question was often framed as a test of humanity: did Neanderthals bury their dead? And if so, were they therefore like us? That formulation now seems too crude. Mortuary behavior can be complex without being identical to later human funerary systems, and similarity does not require sameness of belief. A deliberate burial tells us that the living intervened in the fate of a body. Repeated burial may tell us that this intervention became socially patterned. Beyond that, interpretation must proceed step by step. This is where newer debates about behavioral modernity become especially relevant. Archaeologists and philosophers of human evolution increasingly question the idea that symbolic behavior arrived as a single package, tied to one species at one moment. Burials, pigments, ornaments, technologies, and other complex practices appear unevenly across time and populations. Neanderthal mortuary evidence fits that mosaic. It does not prove a hidden civilization of elaborate ritual, nor does it support the older caricature of minds incapable of social depth. What survives instead is something quieter and more difficult to dismiss: bodies that appear to have been placed rather than merely lost, locations that may have been revisited, and patterns that cross the boundary once drawn too sharply between Neanderthals and Homo sapiens. The evidence remains incomplete, but it is substantial enough that intentional Neanderthal burial is no longer an eccentric possibility. It is a serious archaeological interpretation supported at several sites, though not every claimed grave is equally convincing. And among all those sites, one cave became famous for a detail so evocative that it escaped archaeology and entered popular memory: pollen clustered around a Neanderthal skeleton at Shanidar. For decades, the idea of flowers placed with the dead seemed to offer a direct glimpse of tenderness. The problem is that nature can imitate symbolism with unnerving precision. One lesser-known complication is that archaeologists sometimes infer burial partly from what is missing. If carnivores had prolonged access, smaller bones and exposed joints might be expected to disappear or scatter. Their survival can therefore matter as much as any visible pit, although protected natural deposition can produce similar effects. Shanidar Cave opens in the mountains of Iraqi Kurdistan, a limestone chamber above the valley of the Great Zab. People used it across stretches of time, leaving hearths, stone tools, animal bones, sediments, and human remains layered together. When excavations began revealing Neanderthal skeletons there in the mid-20th century, the cave became one of the most important places in the study of Neanderthal life. Yet one individual, known as Shanidar IV, transformed the site into something more. Around the skeleton, investigators reported dense concentrations of pollen. The possibility seemed irresistible. Perhaps flowers had been deliberately placed with the dead. The interpretation entered public imagination immediately. Flowers are symbols of mourning and remembrance, so the idea appeared to collapse tens of thousands of years of distance in a single image. A Neanderthal body surrounded with blossoms seemed to offer emotional evidence more vivid than any stone tool. It was easy to move from pollen to flowers, from flowers to funeral rites, and from funeral rites to grief or belief in an afterlife. But archaeology rarely permits such a smooth chain of reasoning. Each step must be tested separately, and at Shanidar, the first step itself has become increasingly uncertain. Pollen is microscopic, abundant, and mobile, It can arrive through wind, water, animal fur, food, nesting insects, or sediment disturbance. Some pollen survives for extraordinary periods, but survival does not preserve intention. The original flower burial hypothesis relied on clusters of pollen from several plant taxa around Shanidar 4, apparently concentrated beyond ordinary background deposition. Some plants were later associated in popular accounts with medicinal properties, encouraging even more speculation. Yet identifying pollen does not demonstrate that flowering plants were gathered, carried into the cave, and placed beside a corpse. A reassessment published in 2023 returned to the palynological evidence and the ecology of the cave. One of its most important observations concerned solitary bees. Certain bees nest in ground cavities and can carry concentrated pollen into their burrows. Shanidar Cave preserves evidence consistent with such nesting activity. If bees introduced pollen into sediments around the burial area, then clusters once interpreted as bouquets could have formed naturally. This does not prove that every grain came from insects, but it weakens the claim that pollen itself provides secure evidence for flowers deliberately placed with the dead. The correction matters because the flower story has often been treated as if disproving it would erase Neanderthal mortuary behavior at Shanidar altogether. It does not. The question of whether flowers were placed with Shanidar 4 is separate from whether some bodies at Shanidar were intentionally deposited. Archaeological interpretation becomes more reliable when these claims are uncoupled. A romantic detail can fail while the broader evidence remains significant. New excavations have made that distinction clearer. Decades after the original work, archaeologists returned to Shanidar with methods designed to record sediments and skeletal positions at finer scale. In 2018, additional articulated Neanderthal remains were uncovered close to the earlier burials. The individual became known as Shanidar. The body lay in a constrained position within deposits associated with other Neanderthal remains, renewing arguments that this part of the cave had been used repeatedly for placement of the dead. The discovery was valuable because the sediments could be studied with modern geoarchaeological techniques rather than reconstructed only from old records. Even then, certainty must be earned. Caves are active environments. Sediment accumulates unevenly. Bodies can be covered by natural processes. Rockfall can kill, bury, and preserve individuals without deliberate action by others. At Shanidar, some Neanderthal deaths may relate to falling rock, while other remains appear in contexts more consistent with intentional placement. The cave therefore resists a single explanation for every individual. What survives suggests a mixture of events rather than one uniform practice repeated mechanically over generations. The position of bodies becomes crucial when skeletal elements remain articulated and occupy compact spaces. Archaeologists ask whether the corpse decomposed in a natural hollow or a deliberately prepared feature. At Shanidar, several individuals occur in the same general area of the cave. That spatial repetition is suggestive. It may indicate that later groups knew or recognized a place associated with previous deaths. Yet memory must be handled carefully. Repeated deposition at one location can imply continuity of practice without proving that stories about named ancestors were transmitted across generations. The record preserves patterned action more readily than remembered meaning. There is another subtle possibility. A place can acquire significance without a formal concept of cemetery. Mobile groups repeatedly entering the same cave may develop habits tied to particular spaces, sleeping areas, hearth zones, work surfaces, refuse zones, or places where bodies are left or buried. Over time, behavior itself can create a geography of memory. The dead need not be marked by stones visible for millennia. Knowledge can reside in repeated movement through space. Archaeologists cannot hear those memories, but clustered burials make the possibility difficult to ignore. Shanidar is valuable not because it gives a simple answer, but because it demonstrates how archaeological stories change. The flower burial once appeared to be one of the most emotionally powerful pieces of evidence for Neanderthal ritual. Today, the pollen has a plausible natural explanation involving nesting bees, and the celebrated bouquet can no longer bear the interpretive weight once placed upon it. At the same time, renewed excavation has strengthened interest in deliberate body placement at the cave. One claim weakens while another becomes more carefully grounded. This is how prehistoric mortuary archaeology advances. It does not move neatly from ignorance to certainty. Instead, vivid interpretations are tested, stripped down, rebuilt, or abandoned as evidence improves. Sometimes the result is less dramatic but more meaningful. Shanidar does not need flowers to matter. The cave already preserves Neanderthal bodies in contexts that force researchers to consider repeated attention to the dead, spatial continuity, and perhaps a remembered place within a familiar landscape. The lesson reaches beyond one cave. Grave goods, pigments, animal remains, and unusual deposits must all survive the same scrutiny. An object beside a skeleton is not automatically an offering. A red stain is not automatically ritual pigment. A flower is not a flower until the pathway by which its pollen arrived has been considered. Yet caution does not empty the past of meaning. It prevents meaning from being invented too quickly. And while Shanidar complicates the Neanderthal story, another pattern is visible farther south in Western Asia. There, early Homo sapiens bodies at sites such as Skhul, Qafzeh, and now Tinshemet appear within a growing cluster of Middle Paleolithic mortuary evidence. The question is no longer whether one human species possessed burial while another did not. The more difficult possibility is that different human populations were participating in overlapping traditions of treating the dead.